Don't you have a math video to make? What you doing?
I'm looking for my favorite DVD. Yeah. Well, here's music. Tommy James, Three Dog Night, Cars, ELO, Concert for George, Eagles, Chicago. I can't find my favorite video, the best video I have. You have award-winning characterizations and in the writing, and I think Clint Eastwood directed it, and I think he got an Academy Award for it too. It's my favorite video, and I want to do the math video and then relax tonight and watch my movie, my favorite movie. Oh my gosh, there it is, right there. Oh, got it. I got it. Ice Age. Oh boy. All right, so I've got my favorite video. Now I can make the math one and have movie night tonight. Great. Hello, fellow Falcons. Welcome to another edition of Math is More Than Fun at Pepin. I'm your host, Mr. Newber, and I'm going to try to give you a little different look at mixed numbers today. Mixed numbers, as you know, consist of two things. One is an indication or a number of entire items. And the other one is a fractional part or addition. So I'll give you just a quick example of a mixed number. Let's use the one we've used in the past, 3 1/4. Okay, the 3, whatever we're talking about, whatever the whole thing was, it got fractured. Okay, and we only have 1/4 of it left. All right, could be a China coffee pot, could be a platter. Could be, I don't know, a quart of strawberry. Could be anything. We have 3 of them. We have 4 of them. We have 4 of them, and a certain number of the parts are now missing, and this actually can be thought of as 3 whole ones plus 1/4 of another one. So how did this come up to a real life example? Perhaps of change, and let me give you this example. Let's say you go to the movies with friends or with family, and your ticket costs $8.50. Okay, so we'll put this $8.50. So that's going to be one ticket. Okay, so you or someone with you gives the cashier $10. The cashier does not keep the $10. The cashier takes the $10 because it's more than the $8.50, and they give you back the $1.50. $1.50 plus $8.50 is the $10 that you gave. In math, you can think of a mixed number as kind of like change. When you buy something and you give more than what the charge is, and whoever is taking the money gives you back change. This kind of transaction goes on all the time in the adult world. You may not have had many experiences or opportunities to participate, but you will someday. You'll be buying something, and most likely you're not going to have the exact change in your pocket. So you give them more, you have $10, and you get $1.50 back. This is kind of like a mixed number. A mixed number says the biggest thing here, the biggest thing in a mixed number, is, we can all admit it, is the 3. Whatever we're talking, we might be talking about pickup trucks that were rear-ended on the highway, so there's only portions of them left, and so we have 3 complete pickup trucks and 1/4 of another one because it got rear-ended and they destroyed the cab and they had to rip the bed on it and everything. All right, so this is the main event. Yes, this is it. But there's also this little part over here that's part of it. and you need to demand your change. Give me my change. You're going to want that $1.50. So let's not lose sight that this is also very important in a mixed number. Okay? It's the two things together that make a mixed number. The number of entire items is here. Remember, all mixed numbers look the same because I got a number over here. I can give you one you may have never seen this mixed number. How about this one? 38 and 12/20. All right, that is a big, ugly mixed number. Who wants to add and subtract this thing? Who wants to work with this in a no, nobody does. But you can see, Ronnie Millsap can see, that's a mixed number. Here is a whole number, and this is whatever we're talking about, whatever we are working with, we've got 38 of them. and then the 39th one was divided into 20 parts or pieces, and we only have 12 of those. Remember, if there were 20 in it, we'd have another whole one. So this is simply a mixed number, and when you are working with these and adding them, just think of it that way. That fraction is an important part. You're going to demand your change at the movie theater or at the 7-Eleven, and you demand your fractional part that's attached to the whole number. All right? We definitely don't want to lose sight of that. What you have on your worksheets are mostly addition and subtraction problems involving improper fractions. So let's not lose sight of what you are working on. Is all you have is a fraction. There's the fraction line, all right? We have a numerator and a denominator. This numerator has to be larger than the denominator in order to be an improper fraction, all right? If it's not an improper fraction, if you are doing your worksheets and you see this, well, that's okay. That's okay. That's an improper fraction, but that is not. You might see this on your worksheet. That's okay. We're still going to do the same thing. Remember, both of these have the same denominator. That's called a common denominator, right there. And then all we have to do is that operation with two numerators. So in this one, we are going to add these two numbers, and we come up with 15 over 5. Not 10. We always get the same denominator. We do not change denominators because these are actually sizes. Let me show you this real quick. I want to make sure you understand this, all right? I'm going to offer you a pizza, and that pizza was manufactured, or was baked and delivered, and it was cut into 5 pieces. Now, you never see this because they like to run the slicer, but bear with me, this is math class. Anything is possible in math class. So here are 5 slices of pizza. There's the pepperoni. All right, now I have 12 of those slices. Now that means if there's 5, I'm going to have to draw another one, and I'm going to have to draw another one and just have 2 slices down there, 5, 10, and 2 more is 12. But I don't have to draw all of them. I'm just going to use this one and point, okay? So this 5 comes from this, because in an entire one pizza, in one pizza, in this particular problem, there's 5 slices in the pizza, okay? Now, we're going to add 3 more to that, however many we have. So I could take the time and draw that and just put pepperoni on 3 slices, and then we can count them all up. But all we have to do is add them. Just add the numerators. 12 plus 3 is 15. So I don't have to draw all of that. That's what's not. That's what math. That's why math was developed by the old mathematicians. That's why it was developed, because very possibly before math was understood well enough to communicate it and bring other people in to understand it and maybe do more work on it, they may have had to draw 15 things, 12 things here, and 3 of them over here, and oh my God, because they couldn't add. But this is all we have to do is add these two. And if you go back this far, this is good. I was at this point one time, I think it was 11th grade. Okay, that 12 plus 3, you just set up a problem like you were taught. All right, you make sure you have all your alignment. 2 plus 3 is 5, and 1 here is 15. 15 over 5. This does not change because we're talking about that kind of pizza right there. Okay, so this is one problem. You have an improper fraction and a proper fraction, and you're adding them together, and of course you will end up with a proper fraction. So that's okay. Let's try a different problem. I think there was a subtraction problem. A subtraction problem that took you down below an improper fraction. It went something like this. We will try maybe 11 over 7, and then we are going to subtract 6. And of course the 7 has to be the same in both of them. This is called a common denominator. That means common means it's the same one. All right. Now all we have to do, and you know what I'm going to say next. All we have to do is look at those numerators. Well, in fact, I can even illustrate it this way. You might like this. I'm going to put the equal sign. I'm going to put the fraction line of the answer, and I'm going to put the 7 there. You know why? Because the denominators do not change. So I haven't done this yet. I might need a calculator to do this one, but I know that has to be a 7 in the denominator. Has to be, because denominators do not change. We're talking about pizza with 7 slices in it. And so they're a certain size, and they're perfectly the same size, because this is math class, and they're all the same. All right, this 11 minus 6 is 5. So in this case, what you did is you started out with more than 1. You started out with an improper fraction. You subtracted a number of pieces, but it wasn't more than 1, and you ended up with a proper fraction. That's okay, and that would work as a good answer. Another problem you might have is you have 2 proper fractions, and you actually end up with an improper fraction. So let's look at this. I like to use the 7 because you rarely see that in textbooks and worksheets. So let's do that one again. So we're going to have 4 over 7, all right? And then I'm going to add 5 over 7. And this is a case where you have maybe a party, maybe you have a party, a back to school party in July, okay? When we can all go back to Pepin and be together, all right? And you had it at your house, and so there's one box and it's got 4 slices of pizza in. They were cut in 7s, and the other box has 5 slices in. How much pizza do you have left? How much? Well, all you got to do is, I love doing the different colors. Bear with me. All you have to do is add these 2 numbers right here, the numerators, because that's not going to change. Look, I put the denominator over there already. Why? Because the denominators do not change. 4 plus 5 is what? Thank you, Axel. 9. That's right. All right. 9 over 7. Look, folks, we have more than one pizza. We have more than one. How do I know that? Because 9 is bigger than 7, and 9 is in the numerator. That makes it an improper fraction, and that is more. You may have problems like this where 2 proper fractions added together become what this is. Very simply 9 slices of pizza on a platter at your party. You still have the boxes over here, all right, because you're going to try to recycle those, all right, and you know the 7 pieces will fit in the one box. So you've got a box there. You take those 9. The box won't hold 9. Box holds 7. You have 2 pieces left over. And this is an improper fraction, so if you're asked to give the answer in improper fraction form, there it is, right there. All right, so go through your worksheets when you have improper fractions. If you're struggling with some concept of it, maybe you're looking at it, you don't recognize it, it doesn't look like it's simple. It could be adding or subtracting. Think pizza. Think pizza. That's what I've always taught that way. At-risk students, high school students at Pepin, prisoners. I mean, everybody understands pizza. Everybody's been there. When you're hungry and you lift that lid, and I haven't had supper yet, and there it is. All right. The only thing you have to remember is that pizza is cut into the number of slices that's in your denominator, and then you just go from there. This box had 4 left. That box had 5 left. You put them together, you got 9 slices of pizza, but those slices will not fit in one box because it's already 7 of them make one pizza. Okay, so try to think of it that way. Don't ever give up. You can't. Giving up is not. No, you do your worksheets and do the best you can, and we'll be there in the Zoom meetings to answer your questions. Okay, great. See you in the next video.